Hello and welcome again to this channel and this video series covering dynamic segmentation for Aruba AOS-CX. In this video I will be covering a feature that you might remember when user-based tunneling was first introduced on AOS switch. Let me refresh your memories. With user-based tunneling, traffic is tunneled to a gateway through a GRE tunnel. This GRE tunnel also carries a .1q header that contains the VLAN information. In the first release of user-based tunneling, this was the VLAN that was assigned to that endpoint. For example, if VLAN 100 was assigned to the endpoint through the role, the VLAN ID in the .1q header in the GRE tunnel traffic would be 100. The advantage of this function is that you can distinguish endpoint traffic by VLAN ID, and you can use tagging on the endpoints. This is especially useful in situations where the endpoints require tagging, for example with IP phones. With the introduction of user-based tunneling version 2, really the next version of UBT, the concept of a reserved VLAN was introduced. With this concept, a single VLAN, also known as a reserved VLAN in AOS switch, or ubt-client-vlan in AOS-CX, a single VLAN is used to carry all the traffic in the GRE tunnel. This also means that with the introduction of UBT version 2, it is only possible to carry untagged traffic because you cannot make a distinction anymore which traffic belongs to which VLAN. The feature where you are using the reserved VLAN is called the Local VLAN mode in AOS-CX. With the release of AOS-CX software version 10.6, this first feature of encapsulation is supported again that allows customers to encapsulate tagged traffic. This feature is called the VLAN Extend mode. In this slide you can see that the VLAN ID in the GRE header is defined by the VLAN that is defined in the role. This means that you can have different VLANs per endpoint. Thus, it will allow you to transport tagged traffic through the tunnel. The VLAN ID can be identified because it can be distinguished. For local VLAN mode, the following considerations apply. With UBT, VLANs do not have to be configured on the switch. So the VLAN is only significant at the gateway side where the VLAN is applied to the role on the gateway. And this means that you can use any VLAN for local breakout. And only untagged traffic is supported. Now let me go through extend mode. We know the advantage of this feature, but there are also some considerations to be aware of. Because the VLAN is used for tunneling, this VLAN cannot be a member of the uplink port. Another consideration is that the VLANs that are used for UBT have to exist in the configuration on the switch and on the gateway. And IGMP multicast traffic is flooded on all ports associated with the respective VLAN. To understand the last consideration, you need to know the behavior of multicast and broadcast traffic when using extend mode as opposed to local VLAN mode. Let me first go through VLAN extend mode. In VLAN extend mode, there is a separate tunnel for multicast traffic that is established between the access switch and the switch anchor controller. And user-based tunnels are created for each client connecting to the user anchor controller. So this means that you have separate tunnels for the clients, and there is one tunnel that carries the multicast traffic. For traffic coming from the clients going up to the gateway, whether it's unicast, multicast, or broadcast, that traffic always traverses the tunnel, the UAC tunnel. It always uses the UAC. Now for traffic coming from the gateway going down to the client, unicast traffic is using the UAC tunnel, but the multicast and broadcast traffic uses the multicast tunnel. This also means that multicast and broadcast distribution is performed on the switch. There is no control of multicast and broadcast on the gateway. and IGMP multicast traffic is flooded on all ports associated with the respective VLAN on the switch. Now let's have a look at local VLAN mode. With local VLAN mode, there is no separate tunnel for multicast traffic. There are only user-based tunnels. For the traffic coming from the clients going to the gateway, unicast, multicast, and broadcast traffic always uses the UAC. If we take a look at traffic coming from the gateway going to the endpoints, for broadcast and multicast, the gateway performs head-end replication. So multicast and broadcast control is performed on the gateway. What happens is that multicast and broadcast traffic is converted to a unicast packet and is sent individually to each user through that user-based tunnel. Before we dive into the demonstration, here's the diagram again with all the components. I guess this diagram looks very familiar. So let's cut to the chase and let's show you the VLAN Extend mode and the local VLAN mode in action. Let's have a look at the configuration. One important thing to know is that both functions are mutually exclusive per switch or VSF stack. You must either select VLAN Extend or local VLAN mode. In the previous video, I already covered the local VLAN mode using the UBT user VLAN, and this means that we already actually have this configured. What I have is I have a phone connected to interface 111, as you can see here, and you can see that the phone has been registered. So if I do a show port access client interface 111, you can see that the phone has authenticated successfully and that the role is pushed. Let's have a look at the network trace. Here's the trace. I've applied some filters so that you don't see a lot of traffic, so you only see the relevant traffic here. So this is a packet like an LLDP packet coming from the phone. You can see the MAC address here, 2C41387F05AB. And what you can see in the GRE header is you can see this 802.1q field here. If I extend that one, you can see that it's using VLAN ID 4091, which is the UBT user VLAN. Now that was a quick demo. Let's move to the VLAN Extend mode. Let me first enable the VLAN Extend mode on the switch. I do that with the following command. So let's go into configuration mode, UBT mode. Was it VLAN Extend? And to move back, to move the switch back to local VLAN mode, you only need to negate the command. So you only have to do no UBT mode. Okay, so really very simple. One of the important requirements for VLAN Extend mode is that the VLANs must be configured on the switch. Okay, so let me just show which VLANs are there. VLAN 110 exists on the switch, and that is actually the VLAN that we will be using for the phone. The other thing is that this VLAN should not be a member of the uplink port. So if I do a show VLAN 110, you can actually see that VLAN 110 is a member of interface 1148, and 1148 is the uplink port. So I need to remove that VLAN from the uplink port. So let's go into that interface and do a no VLAN trunk allowed 110. Next is to configure the VLAN in the role. And so this parameter will define the VLAN that is assigned to the endpoint, and in this case, the IP phone and the assigned VLAN ID that will be used in the GRE encapsulated traffic. The VLAN is configured in the role here. Let's see. So in the local VLAN mode, obviously you don't have to define a VLAN because that VLAN is not significant on the switch. It is only significant on the gateway. So that means that you only need to have that VLAN configured on the gateway. In VLAN Extend mode, however, you have to configure that gateway. So what you can do is allow VLAN 110 on this trunk because you're using tagging. Obviously, that port becomes a trunk port, and that's really it. Save this one and move to the switch. What I'll do is I will bounce the port so that a new authentication is triggered. And let me just move back to the access tracker and see when that happens. I can see the accept message here, and let me just check the role. You can see that the role is pushed with the VLAN trunk allowed 110 parameter. And here's the switch status, the client status. You can see that VLAN 110 is applied to interface 111, and you can see that the client has been authenticated successfully. If I do a detail, you can get all the detailed information here. I guess you can see that the role is downloaded. UBT mode is VLAN Extend, and the allowed trunk VLAN is 110. Let's move to the trace. This is a trace coming from the phone. You got the GRE packet here, and you've got the 802.1q field here. What you can see here is this is strange because it is not stating VLAN 110, but VLAN 1. Now let me explain the reason for that. The phone that I'm connecting is not using tagged traffic. It is using untagged traffic. It is not configured to send tagged traffic on VLAN 110. If that is the case, you see this behavior. So in the trace, you will see that the 802.1q VLAN is set to VLAN 1. Let me show you how I can solve this. Let me go back to the role in ClearPass. Because the phone is not tagging any packets, I actually have to remove this VLAN 110 as trunk port and set the access VLAN to 110. What happens in this situation is that the phone sends untagged traffic into VLAN 110, and the UBT tunnel will mark the GRE header with VLAN 110. I have bounced the switchboard, and you can see the authentication here, and I am pushing VLAN 110 now as access VLAN. And let's move to the switch. Show VLAN 110. VLAN 110 is assigned to interface 1, and show port access client interface 111 is successful. Okay, so that's all working. And let me move to the trace. Okay, so you can see the HTTP request coming from the phone, and now you can see that the 802.1q field in the GRE header is set to VLAN 110. And now finally, let's see what happens if we assign a VLAN to the role that does not exist on the switch. Okay, let me just show that VLAN. Show VLAN. Now let me assign, say, VLAN 150 to the role and see what happens. 150. Save. Before I bounce the switch port again, let me also start some debugging on the switch because I want to see what happens when things go wrong. Okay, let me do a debug destination buffer and do a debug port access services. Yeah, that's without that hash. Debug service. And let me do a clear debug buffer. Let's bounce the port. Let's move back to the access tracker and see if the authentication is successful. And now VLAN 150 should be pushed. There you go, VLAN 150. And let's see what is happening here. Okay, when I do a show port access client interface 111, I can see that the role push has failed. Let me do a show debug buffer. See what's in there. When I go through the debug log, you should be able to see at a certain stage that there is a problem with the VLAN. I can see that here. VLAN with ID 150 is not found, and you can see some more debug messages where you can see that the profile apply failed and stuff like that. So your debugger is really a good source to find what is going wrong here. And in this case, VLAN 150 is not found. This means that I have to create VLAN 150 on the switch and of course also on the gateway. And let me do just that. Just create VLAN 150 and do a shut, no shut, and see what happens. The access tracker shows that VLAN 150 is pushed. New authentication, and let me just do a show port access client interface 111, and I still see a fail. Now, why is that? Well, I have configured VLAN 150 on the switch, but on the gateway side, there is no VLAN 150. So I also need to create that VLAN on the gateway side. Let me just call that one VLAN Extend, VLAN 150. Let's push that VLAN. And I will bounce that switch port again. Show port access client interface 111, and now it should be successful. There you go. This proves that if you want to use VLAN extend mode, the VLAN configuration has to exist, or the VLANs that you're pushing through the roles have to exist in the configuration on the switch and on the gateway. Let me show you the trace. Here's the trace. You can see the GRE packet here coming from the phone, and you can see the 802.1q field with the VLAN 150 identifier in there. So that's all good.
I sense something, a presence I've not felt since...
Well, and that's it for now. There's much more to come on dynamic segmentation. Watch the space. If you like the video, you can hit that thumbs up button, and if you have any questions or suggestions, let us know. Thanks for watching again, and I hope to see you back soon on this channel.